The exponent of a number says how many times to use the number in a multiplication. In 8 squared, the 2 says to use 8 twice in a multiplication. So 8 squared is equal to 8 times 8, and that is equal to 64. To identify the parts of this example, 8 is the base, and the 2 here is the exponent or index or the power. In other words, 8 squared could be called 8 to the power of 2, or 8 to the second power, or simply 8 squared. Exponents are also called powers or indices. Welcome to Puzzle Academy, the place where we can help you to build the pieces to the puzzle of success. Thanks for choosing to spend time with us today. If you are new here, we are happy to welcome you. Be sure to subscribe and follow us on Instagram at puzzleacademy.learn. Let's have some more examples. The first one is 5 cubed, and that is equal to 5 times 5 times 5, and that is equal to 125. In other words, 5 cubed could be called 5 to the third power, or 5 to the power of 3, or simply 5 cubed. Now for the next example, 2 raised to 4, and that is equal to 2 times 2 times 2 times 2, and I believe that is equivalent to 16. In words, 2 raised to 4 could be called 2 to the fourth power, or 2 to the power of 4, or simply 2 to the fourth. Exponents make it easier to write and use many multiplications. Example, 9 raised to 6 is easier to write and read than 9 times 9 times 9 times 9 times 9 times 9. You can multiply any number by itself as many times as you want using exponents. So, in general, a raised to n tells you to multiply a by itself, just like this. So there are n of those a's. Sometimes people use this symbol above the 6 on their keyboard as it is easy to type. Just like in this symbol, 2 raised to 4 is the same as this symbol. So also that is 2 times 2 times 2 times 2, and that is equivalent to 16. And now we talk about negative. What could be the opposite of multiplying? Yes, that is dividing. So we divide by the number each time, which is the same as multiplying by 1 over the number. For example, 8 raised to negative 1. 8 is the base, that is equal to 1 over the base, or 8. And if we simplify it to the decimal form, that is 0.125. We can continue on like this. For example, 5 raised to negative 3. Also, that is equal to 1 over the number. The number is 5, which is the base. 1 over 5 times 1 over 5 times 1 over 5. So if we simplify it, that is 0.008. But it is often easier to do it this way. 5 raised to negative 3. The same example could also be calculated like 1 over 5 times 5 times 5. And that is equal to 1 over 5 raised to 3. Also, if we simplify 5 cubed or 5 raised to 3, that is equivalent to 1 over 125. And if we convert it to decimal number, that is 0.008. Now, you have negative, flip the positive. That last example showed an easier way to handle negative exponents. In this guide, a raised to negative n is also equivalent to 1 over a raised to n. The first process that we did here is to calculate the positive exponent, a raised to n. Then we take the reciprocal. For more examples, the first given is 4 raised to negative 2. That is the negative exponent. Now we get the reciprocal of positive exponent, that is 1 over 4 squared. And the answer would be 1 over 16. And if we simplified it into decimal form, that is 0.0625. The next one is 10 raised to negative 3. The reciprocal of positive exponent is 1 over 10 cubed. And the answer would be 1 over 1000. And the decimal form is 0.001. And last but not least, quantity negative 2 raised to negative 3. The reciprocal of the positive exponent is 1 over the quantity negative 2 raised to 3. And the answer would be 1 over the quantity of negative 8. And that is equal to negative 0.125. What if the exponent is 1 or 0? If the exponent is 1, then you just have the number itself. Example, 9 raised to 1, the answer must be itself, 9. Now, if the exponent is 0, then you get 1. For example, 9 raised to 0, that is equal to 1. Always 1. But what about 0 raised to 0? It could be either 1 or 0. And so people say it is indeterminate. It all makes sense if you look at that table. You will see that positive, 0, or negative exponents are really part of the same, fairly simple pattern. For example, powers of 5. 5 squared, that is 5 times 5, that is 25. 5 raised to 1, the answer must be itself. 5 raised to 0, the answer is 1. 5 raised to negative 1, the answer would be 1 over 5. And 5 raised to negative 2, the answer would be 1 over 5 times 1 over 5, and etc. Now be careful about grouping. To avoid confusion, use parentheses in cases like this. Now for more understanding about the beauty of exponents, we will talk about the laws of exponents in our next quest.